Welcome back to your own YouTube channel, Shri Chaitanya Goshala. Today, my name is Anirudh Mehta. I am a chemistry faculty at Shri Chaitanya Dr. B.S. Rao Nagar, or you can also call it as Goshala Zone. I am going to tell you about a very interesting and very important topic from NEET point of view, which is a topic of organic chemistry, which is known as isomerism in organic chemistry. So before starting with this topic, let me tell you, every year in NEET, at least 2 questions come from this particular topic directly or indirectly. Because in many of the organic reaction like SN1 reaction, SN2 reactions and other different types of reactions, when the products are formed, the final products may exist as different isomers. So when they ask you how many total products are formed in this particular reaction, how many possible products are there anyways you have to take this into the account of different isomers. So it becomes a very important and interesting topic from that point of view. So let us start with this. What are isomers or what is isomerism? So guys, sometimes what happens is there will be different compounds, but they will have same molecular formula. Okay, first grasp this information in your brain. Different compounds, but they will have same molecular formula. Those will be called as isomers. Something like, let me give you an example here, then we will start with the basic classification. Like if I talk about a particular formula C2H6O. C2H6O. Now there are two different things possible with this particular formula. One is ethanol, as all of you know the formula CH3CH2OH. One is dimethyl ether, which is CH3OCH3. Now obviously they are very different compounds. They have different functional group, so they will have different properties. So with this we will start with our class today. What are isomers? Isomers have same molecular formula but different properties, different physical or chemical properties. Today the class is a short and simple class where I will give you tricks and tips to draw total number of isomers for any particular compound. So we will not be going deep into the classification of the classification of isomers. That is a separate topic itself. It requires time. But today I will tell you that how to deal with questions where they ask you calculate the total number of isomers of a particular formula. Okay, let us start with it. So first of all, I am asking you what are isomers. So isomers have same formula, different properties. Now actually isomers can be further classified into two different types. If you look at this cat here, on this cat, what do you see the difference? Can you see that this cat has a tail over here, but in the other cat, I have put a tail over here. So these are two different cats, obviously, it can't be the same cat. This is a cat which has a different constitution only, different structure only. One has a tail at the back, one has a tail in the front. So this is an example of structural isomers. Structural isomers. Okay. This is an example of structural isomers. So any two isomers which have same molecular formula but different structure. One example I've given you here, you can see here, this is a N-butane. This is a N-butane, which is just 4 carbons in a straight chain. But if I want to draw its another structure, I can have isobutane, which is also a 2-methyl propane. I am just hoping that all of you know the IUPAC nomenclature before this class and you know the basics of isomerism, so that we are going to deal with just calculating the number of isomers. So this is an example where structure changes. Other type of isomerism is, if you look at this cat and this cat, what is the difference between the two? Both cats are looking almost identical. I'm saying they have the tails at the same position, all the limbs at the same position, but both of them are nothing but mirror images of each other. They are non-superimposable mirror images of each other. If I try to impose this cat on this cat, they will not be superimposed, just like my hand. If I take my right hand and my left hand, they are mirror images of each other. If I try to superimpose them, They will not superimpose. So my hands have same structure. My hands have same structure, but what is different? The difference comes in the spatial arrangement of my fingers. In this case, my thumb is on the right hand side. In this case, my thumb is on the left hand side, and so on. So this particular type of isomerism is an example of stereoisomers or space isomers or 3D isomers. Okay, so what are they? They have same molecular formula as well have same structure, but they differ in spatial arrangement of different groups and atoms. Okay, different spatial arrangement. That is why the name stereoisomers. Stereo means spatial. Okay, and structural isomers have same molecular formula but different structure. So this much we know. And now let us start with, if they give you a particular formula, like they say C3H8 or they say C3H6 or they say C4H10, then how do you calculate the total number of isomers? There is no trick to directly remember all of them, okay, but we'll have to draw them. But I'll give you some tips so that you can draw them really fast. Let us start. Counting the total isomers. First, I'll help you to count the structural isomers. Later, we'll talk a little bit about stereo in this class, if it is possible. Degree of unsaturation is the first thing you'll have to find. This is your step 1. Means you need to know that how many rings or how many pi bonds are present in a particular compound. We call that as unsaturation. So what is degree of unsaturation? It is number of rings plus pi bonds. Rings plus pi bonds together in the organic compound. In the organic compound. Let me give you an example. If I take this particular alcohol, its du is what? Its du is 0. Can you see any ring? Can you see any pi bond? Answer is no. So 0 ring, 0 pi. But if I make this type of alcohol, it has degree of unsaturation 1. Okay, it has a degree of unsaturation 1. And if I look at this particular alcohol, it also has degree of unsaturation 1. So in this one ring was present, in this one pi bond is present. Very important point that you can remember from here is, whenever degree of unsaturation is same and number of carbons and other things are also same, then formula will also remain same. If you see carefully, it is C, 3 carbon. Here also 3 carbon I am taking. This is CH2 group, CH2 group, CH group. This is CH2 group, CH group, CH2 group. So if I check their formula, both of their formula is coming exactly the same, which is 3 carbons are there. If you count the total number of hydrogens are coming 6 here. In this also 2 plus 2 plus 1 plus 1, 6. Here also 2 plus 2 plus 1 plus 1, 6 and 1 oxygen. So very important, when you will have isomers, in isomers, degree of unsaturation will remain same. So these two people are isomers of each other. Okay, how I have drawn them, I'll just help you with it. Okay, so these two are isomers of each other. How do I know? Because their degree of unsaturation was same and their carbons and heteroatoms were same. So automatically they become isomers. Okay, so right now our concern is, if any formula is given, how do we reach to the isomers? Before that, please find out the degree of unsaturation, because you will need to know whether the compound is saturated or unsaturated. Okay, let us start. How to find this degree of unsaturation? There is a simple formula for this. Degree of unsaturations for any compound will be number of carbons plus 1. Number of carbons plus 1 minus hydrogens plus halogens minus number of nitrogens whole divided by 2. Okay, right now leave it from where this formula is coming. Right now just learn this formula so that you can solve some important questions. Okay, so du, it is going to help us to find how many pi bonds or how many rings are there in a particular compound. Okay, let me give you one example, then we'll start with it. Let me give you an example of a simple hydrocarbon C6H6. All of you know what is C6H6. Okay, what is C6H6? It is nothing but benzene. But let me see, if I don't know it is benzene and I want to know how many unsaturations are there in the benzene, how do I calculate? I would say du is carbons plus 1 minus hydrogens are 6, halogens are 0, nitrogens are 0 divided by 2. So I get 6 plus 1, 7, 7 minus 3, 4 unsaturations. 4 unsaturations. And now let us draw the structure of benzene that we know. I could draw now hundreds of structure of C6H6. Just I need 6 carbons and 4 unsaturations. What do I need? 6 carbons and 4 unsaturations. Let me draw 2-3 of them. We don't have to draw all of them for C6H6. It will become a long question otherwise. So C6H6, let me draw the first one that you know already. It is going to be 6 carbon in the same ring. So I have already satisfied one unsaturation, one ring. Now 3 more unsaturations. I can keep 1 pi bond here, 1 pi bond here, 1 pi bond here. Now the du becomes 4. Du becomes 4. 6 carbons and 4 unsaturations. In them, 1 is ring and 3 are pi bonds. I could have drawn something else. I could have put 5 carbons in the ring, 1 carbon outside, like CH3. And then I need 3 more pi bonds. So let me take, okay, I could have taken 5 carbons in the ring. Let me take 5 carbons in the ring, like this, 1 carbon outside. And I need now 3 bonds. So I'll take 1 pi bond here, 1 pi bond here. Let me take 1 pi bond outside the ring. This is also an isomer of benzene only. Okay, just I need to satisfy the carbons, I need to satisfy the heteroatoms, and I need to satisfy the degree of unsaturation. So what do you need to satisfy? Carbon, heteroatom, unsaturation. Automatically 2 compounds will have same formula. I could think of something else. I could think of an open chain of 6 carbon, something like this, open chain of 6 carbon. Right now unsaturation is 0. I need to put 4 unsaturation. Let me put 1 triple bond here. 2 unsaturations are done. Let me put 1 double bond here. 3 unsaturations are done. Let me put 1 more double bond here. Unsaturations are 4. All these people are nothing but isomers of each other. Okay, all these are isomers of each other. I hope it is clear to everyone. Now let us start with the examples. You can pause the video whenever you wish, like writing the things. Okay. All right. Let us start with example number 1. I am starting with a compound without any heteroatom. Then slowly we'll go towards the heteroatom. I'm starting with something like C4H8. They are asking you to find total isomers of C4H8. Okay. First one I am trying, then next one I'll ask you to also try along with me. So first one is, first thing I'll find its degree of unsaturation, du. It will come out to be carbons plus 1 minus hydrogens by 2. 5 minus 4, which is 1. So always have a plan before drawing the isomers. Have a plan in your brain. My plan is I will make 1 pi bond compounds first and then 1 ring containing compound. So I'll make a partition in between and we'll say here I will make 1 ring type of compound. Then I will not put any pi bond inside the ring because unsaturation is only 1. Either I can make a ring or I can put 1 pi bond. So here I will get some alkenes, obviously open chain with 1 pi bond. Here I will get some cycloalkanes. Cycloalkanes. Now, so strategy is simple. Separately draw ring compounds, separately draw the open chain compounds. In the open chain compounds, always start with maximum carbons in the parent chain. So I am starting with 4 carbons in the parent chain. So in the alkane, I will first start with 4 carbons in the parent chain. After you have drawn your parent chain, Now think of different positions where you can put the functional groups or the unsaturation. So in a butane, I can put a pi bond here at number 1. At here also will be number 1. So it will become but1ene. Or I could do it on the number 2. It will become but2ene. But1ene, but2ene. Okay. Nothing else is possible. So when you are done with one longest chain, then try to cut down the chain to one less carbon. So I will make a chain of 3 carbon now. 1, 2, 3. And put one carbon, one extra carbon as a branch somewhere. So I'll make this isobutane chain. Now, what are the positions to keep pi bond? The position is only one, because you can see here, if I keep a pi bond here, here or here, all will become the same compound only. It will be 2-methyl prop-1ene. 2-methyl propene. This is but 2-ene. This is but1ene. Okay. If the question has asked you just the structural isomers, 3 open chain structural isomers will be there, closed chain separate. 3 open chain structural isomers are there. If they ask you total isomers, for stereo, we should know that we can count the cis and trans geometrical isomers as well. The simple conditions for any alkene to show geometrical isomerism is just that when you look at that sp2 carbon, the carbon carrying the pi bond, both the carbons must have 2 different groups attached to them. What I mean to say is, here can you see both are hydrogens? Yes. So it cannot show GI. It cannot show geometrical isomerism. So it is a single compound. But here can you see on this carbon there is one hydrogen and one methyl, 2 different groups. On this carbon also there is one hydrogen and one methyl, 2 different groups. So yes, this system will start showing us geometrical isomers. And whenever there is one unsaturation which is showing GI, there are 2 compounds possible there. One is cis, one is trans. So in but2ene, actually it will be 2 compounds if they ask us to check total isomers including stereo. It will be cis but2ene, which is going to look like this. And other will be trans but2ene, which is going to look like this. If you have the basics of the isomerism with you, I hope all of you are clear with this 2 possibilities here. In this case, if you see, this carbon of the unsaturation is attached to 2 same groups, CH3 and CH3. So in this case, obviously it will not exhibit GI. So total open chain compounds till now I have got are 4. 1, 2, 3, 4. 4 open chain compounds. Okay. Now let us check the ring compounds. Again, the same strategy. Start with the maximum number of carbons in the ring. So starting with 4 carbons in the ring, I can make a cyclobutane. Don't worry about hydrogens. They will automatically balance out each other. Cyclobutane. Okay. I can't put any pi bond. So just a cycloalkane I have to draw. 4 carbon, only one possibility. Cut the chain to 3. Cyclopropane. One more carbon I have to keep. Whether I keep a branch here or here or here, it's the same only. So I'll keep it anywhere. It will become methyl cyclopropane. Methyl cyclopropane. One very good tip that I can give you is whenever you are writing different isomers, please always write their IUPAC name along with them. Whenever you will write their IUPAC names along with them, you will never go wrong. Why I'm saying this is sometimes you will make a particular compound, but you will make it 2 times and you will count it as 2 compounds and your answer will go wrong. Something like, you might say, sir, I am getting 2 different compounds. One of them is looking like this. And one of them is looking like this, sir. Okay. And we can generally do this mistake of not counting properly. So these 2 are same compounds only. It's just as one is lying down, one is sitting like this. Okay. So both are same compound here. They don't have any difference. They are the same compound only. Okay. So in such cases, always it is useful if you name those compounds so that if any identical names are coming, you can know that by mistake you have drawn the same compound. Started with the 4, went to 3. I can't go to 2 because there is no ring of 2 possible. And so this cannot show any geometrical isomerism. This particular compound also does not show any geometrical isomerism. So total comes out to be how many? Total comes out to be 4, 1, 2, 3, 4, 4 open chain and 2 closed chain. Answer is 6. Okay, 6 of them are possible total. If they ask structural only, that means they are saying do not check for any geometrical isomerism or optical isomerism. Then answer would be 5. 1, 2, 3, 4, 5. I will not consider cis and trans as the separate ones because they are not asking us to check the stereoisomerism. I hope this point is clear to everyone. Now let me go on with the second example. First, I want you to try it. And then we are going to see. Second example, example number 2. Let me take an example with the heteroatom. Now, I'm taking the example of C4H10O. Now, there is one oxygen here, everybody. Now, as soon as you see any heteroatom, the functional group table should go to your mind. Functional group table. Which all functional group have one oxygen? If I ask you, you might say, sir, alcohols have one oxygen. Sir, ethers have one oxygen. Sir, aldehydes have one oxygen. Sir, ketones have one oxygen. So these are the ones which have one oxygen. Now if I say, what if I calculate the DU first, degree of unsaturation, and I can ask you, what if there is no pi bond? Then which functional group will you choose? Will you choose alcohol? Will you choose ether? Will you choose aldehyde? Will you choose ketone? You will say, sir, what are you saying? Just now you said there is no pi bond. Why should I choose any aldehyde? Why should I choose any ketone? So I will draw only alcohols and ethers. That is very important. So as soon as a heteroatom comes, in your brain you can think of the functional group table. There are 10 to 12 functional groups only, and all of you should know how many oxygens and pi bonds are there in each functional group. Okay, let us start this question. Now here I'll give you one small trick to draw the structures also. First thing, I'm checking degree of unsaturation. There are 4 carbons plus 1 minus hydrogens plus halogens. Halogens are 0 minus nitrogens are 0 by 2. 5 minus 5, 0. Means I don't have to think of any pi bond, any aldehyde, any ketone, any ring. It has to be an open chain compound, open chain saturated compound. Open chain saturated compound. So my strategy here is I would draw alcohol separate, ethers separate. Two types of compounds I have to draw now, alcohols and ethers. So I will draw alcohol separate, open chain alcohol separate, and open chain ether separate. Alcohol separate and ether separate. Okay, so let us start. First, in order to draw alcohols of 4 carbon, just a second. In order to draw alcohol of 4 carbon, now I can give you one trick. Whenever you want to draw 4 carbons chain, or whenever you want to keep 4 carbon, there are 4 ways to keep 4 carbon. How many ways? 4 ways. Just remember this small thing that I am telling you. I will call it as isomerism in alkyl groups. Isomers of alkyl chains. Isomers of alkyl chains. Beta, it's very simple that whenever you have 1 carbon, there is only one way to keep it. So methyl can be present just as a CH3. Okay, just as a CH3. So one way to keep single carbon. I'll tell you how to use it in different cases. One way to keep single carbon. One way to keep 2 carbons, which is just ethyl. Okay, to keep 1 carbon anywhere, you have one way. To keep 2 carbons anywhere, you have only one way. To keep 3 carbons, you have 2 ways. One is you can keep as propyl. One you can keep it as isopropyl. So whenever you want to attach 3 carbons anywhere, just think you are having 2 ways to attach 3 carbons. So propyl has 2 ways. 3 carbons have 2 ways to attach, propyl or as isopropyl. Propyl or isopropyl, 2 ways. And wherever we have 4 carbons to attach, there will be 4 ways. One is butyl. One will be isobutyl. One will be secondary butyl. This is secondary butyl that I am writing here. You can write the name also. This is N-butyl. This is secondary butyl. Then you can have a isobutyl. Isobutyl, which looks like this. Iso group is a V-shaped group like this. A carbon attached to 2-methyl. This is the iso group. Okay, this is isopropyl. This is isobutyl, total 4 carbon. And there is a tertiary butyl possible. Like this. So whenever you want to keep 4 carbons, there are 4 ways by which you can do that. 4 ways to keep 4 carbons. How it will help you see now. I had to make a 4 carbons alcohol. So I can directly think in my brain that there are 4 alcohols only possible. If I have to make a 4 carbons alkyl halide, only 4 options. Butyl alcohol, secondary butyl alcohol, isobutyl alcohol, tertiary butyl alcohol. Generally in NEET, when a question comes, they will not give more than 4 carbons in a particular chain. If they give, let's say 5, then there are 8 ways to keep 5 carbon. Okay, 8 ways. 8 ways, everybody. 5 carbon, there are 8 ways. 8 ways to keep a 5 carbon alkyl. A 5 carbon alkyl can be kept in 8 ways. Okay, if you want, I can just show you what are the 8 ways. One is just a pentyl. Let's say you had a pentane. From pentane, you could do attachment at carbon number 1. It would look like this. You could do attachment at carbon number 2. Then it would look like this. You could do attachment at carbon number 3. Then it would look like this. Okay. 3 types from where pentane can give you the attachment. Then we have another isomer of pentane, which is called as isopentane, which can do attachment from different sides. This is what a isopentane looks like. 2-methyl butane. If I look at 2-methyl butane, this is isopentane actually. Okay, this compound. Now it can have how many different ways of attachment? One way. This and this carbon would have same attachment only. So 1 way, 2 way, 3 way, 4 way. 4 ways will be there. Other way would be looking, if I attach from this particular carbon, it has 2 methyls and 1 ethyl like this. If I attach from this carbon, it will have a methyl. Just a second. Okay. If I do attachment from this particular carbon, it will have a methyl group and a isopropyl group, which would look something like this. Okay, like this total 8 you are going to get. Like this total 8 you are going to get. I am just drawing them. If I do attachment from here, if I do attachment from this side, then this is the way pentyl would look like. These are different types of pentyl. 1, 2, 3, 4, 5, 6, 7. And the last one would be the neopentyl. Generally, for the 5 carbons, they don't ask. But in case a question comes where 5 carbons you have to keep, just make sure there will be 8 ways to keep. If you start drawing them one by one, it will take a lot of time, I am telling you. So just learn them, it will be much better. There are 8 ways to keep the 5 carbon. Okay, not important. Again, for the NEET, it is not important. Shall we start? Can we remember now this much? That 3 carbons alkyl, there are 2 ways to form. Propyl, isopropyl. And 4 carbons propyl, there are 4 ways, 4 carbons alkyl, there are 4 ways to keep. Butyl, secondary butyl, isobutyl and tertiary butyl. Let us start. So now the question was, to make an alcohol of 4 carbon, so I have to keep 4 carbons, I can keep them in 4 ways. One will be butyl, secondary butyl, isobutyl, okay, I'll just draw it here, and tertiary butyl, a carbon attached to 3 more carbons, tertiary butyl. Okay, now keep OH attached to them. So I will have a N-butyl alcohol or butane 1-ol, secondary butyl alcohol or butane 2-ol, isobutyl alcohol, or the other one which is going to be tertiary butyl alcohol. These are the only 4 alcohols possible. Otherwise, how would you would have started the question is first thinking of the longest chain. So I'll keep a chain of 4 butane. Then there are positions, how many possible? There are 2 positions, butane 1-ol, butane 2-ol, like that you would do. Then you will say, sir, I'll cut down the chain from 4 to 3. So I'll make a isobutane, and then in that I will check the position. There will be 2 positions possible. Otherwise, this is better to directly remember that butyls can have 4 different arrangement: butyl, secondary butyl, isobutyl, and tertiary butyl. So 4 alcohols are there. I'm just checking the structural isomers here. If they ask for stereo, there is little bit extra knowledge of optical isomerism which is required, which we will discuss in some other class. Right now, just check for the structural isomers. 4 alcohols, finished. Now, ethers. Ethers have oxygen, this side also carbon, this side also carbon. Now, 4 carbons total, in how many ways can I keep? I can keep a 2:2 ratio, or I can keep a 3:1 ratio. If I keep 2:2 ratio, 2 carbon, only one way to keep, which is ethyl. 2 carbon, one way to keep, which is ethyl. So I will get a diethyl ether. If I make 3:1, then obviously you can tell me yourself. I just told you, 1 carbon only methyl you can keep. 1 carbon only methyl you can keep. But 3 carbon, there are 2 ways. I could keep a N-propyl. I could keep a isopropyl. I could keep a N-propyl. I could keep a isopropyl. This gives us total how many ethers? 3 ethers and 4 alcohols. So total structural isomers are how many? They are 7. 7 would be the answer. If they ask you total isomers, total including stereo, total isomers, then you will have to check for the optical activity as well, which depends on the chiral carbon. Any carbon which is attached to 4 different groups will show optical activity as well. In that case, you will have to count 2 compounds there. One is the compound that you have written, and one will be its mirror image that requires knowledge of optical isomerism. Okay? Right? So in this particular case, if I see the optical isomerism, there is where, let's check for the chiral carbon. This is CH3, CH2, CH2, CH2. So there is no chiral carbon here. Okay? Every carbon has more than one hydrogen. CH3, CH2, look at this carbon, CHOH, CH3. So this carbon is attached to 4 different groups. It is attached to a OH, a hydrogen, a methyl, and a ethyl. So this is a chiral carbon. I should count 2 compounds here. One of them will be dextrorotatory butane 2-ol. One of them should be levorotatory butane 2-ol. 2 optical isomers will be there. Okay. So here if I check the total, 1, 2, 3, 1, 2, 3. This is not chiral because here 2 hydrogens are there. Here also 2 methyls are there. So not a chiral carbon. In this particular case also I can't see any chiral carbon because this carbon is attached to 3 same groups methyls. So it's not chiral. Here also I can't see anything chiral. It is CH2, it is CH2, it is CH3, it is CH3. No chiral, single compound. Here also nothing is chiral, and here also nothing is chiral because this carbon is attached to 2 methyl groups. Okay, so these are not chiral. So if they asked total, if they asked us total isomers, then one extra I will add and make the answer 8. Make the answer 8. I hope it is clear to everybody. Now let me give you one more example and few homework questions so that you can tell me their answers in the chat box. By knowing the number of alkyl chain isomers, you can easily answer any question quickly. Let me give you one example of a little longer one, but you will be able to tell me the answer pretty quick. For example, let me say how many amines are possible for C5. How many amines are possible for C5H13N, everybody? This is a very long answer. Too many will be possible, but let me show you how to answer them quickly. Okay, I will not even draw them. I'll just quickly tell you the answer. First thing you find du. Du comes out to be carbons plus 1 minus hydrogens plus halogens minus 1 nitrogen by 2. 6 minus 6, 0. Okay, so no pi bond is allowed to keep. So my strategy is what? My strategy is to keep just primary amines separately, secondary amines separately, tertiary amines separately. Everybody be careful and see this by the trick I am doing this. Primary amine. I have to keep 5 carbons, beta. 5 carbons, did I tell you there are 8 ways to keep? So there will be 8 ways of primary amine. 8 compounds will be there. Just the structural I am asking. For stereo, you will have to draw them, sorry. Structural, 8 ways. 5 carbon, 8 ways. If you want me to draw, I will quickly draw them. You can just see here and get over with it. This is our pentane. I am keeping 5 carbons in the same. 5 carbons in the same chain. 5 carbon. Now NH2 can attach at different position. If I attach it on first position, pentane 1 amine. If I attach it on second position, pentane 2 amine. If I attach it on third position, pentane 3 amine. I should not take this much time. I would directly say the answer within a second, 8. But in case you want to see which 8, so these are the 3 amines which are possible from just the pentane. Now convert the pentane to isopentane, which is a 2-methyl butane. On a 2-methyl butane, there are 4 different positions. 1, 2, 3, 4. So I'll have amine on number 1. This number 1 or this number 1 is same only. I can have amine on number 2. Amine on number 2, which will be here. I can have amine on number 3. Okay, numbering, I am not saying by UPSC way, I am just saying this compound. So if it will be numbered from this side, it will be a 2 amine with a 3 methyl. So 3 methyl butane 2 amine. 3 methyl butane 2 amine. Or I can put it on the last carbon over there and call it as 3 methyl butane 1 amine. Okay, so these are the possible ones with the isopentyl, and then we have a neopentyl, which is going to be the last one, this one. Okay, next time don't draw them, directly learn 5 carbons. Alkyl can have 8 different arrangements. I hope it is clear to everyone. Primary amines 8 ways. Secondary amines. Now secondary amines will have a nitrogen, this side also alkyl, this side also alkyl. 5 carbons, how can I dissect them? I can dissect 5 carbons as 4:1. I can dissect 5 carbons as 3:2. Now with the trick we'll do 4:1. 1 means I can keep only methyl, but 4 means I can keep how many ways? How many ways? Say it out loud. 4 ways. So 4 ways I can keep. So answer will be 4 ways here. 4 ways. Okay, I can keep a butyl, methyl. I can keep a secondary butyl, methyl. I can keep a isobutyl, methyl. I can keep a tertiary butyl, methyl. 4 ways. 3:2. How many ways? 2 ways. 3 carbon means I can put a propyl or a isopropyl. 2 carbon means only ethyl possible. So on the right hand side, I'll make only ethyl, but on the left hand side, I could make a N-propyl. I could make a isopropyl like this. Correct? Is it clear to everyone? So, how many primary amines I told you? Just count them now. Primary amines I told you 8. How many secondary amines we found? 4 for the 4 is to 1, 2 for the 3 is to 2, 4 plus 2, 6. 6. And then tertiary amines means a nitrogen will attach here also with alkyl, here also with alkyl, here also with alkyl. 3 sides alkyl. So I can dissect 5 carbon as what? I can dissect them as 2:2:1. What else could you do? If you take 3, 1, 1, that is also possible. 3 is to 1 is to 1. 2 is to 2 is to 1. 3 is to 1 is to 1. 2 is to 2 is to 1. 3 is to 1 is to 1. There is no other way. 3, 1, 1 or 2, 2, 1. 2, 2, 1. Ethyl, ethyl, methyl, only one way. Because 2 can be as ethyl, 2 can be ethyl, this is methyl. So a nitrogen with a ethyl, with a ethyl, with a methyl. This is the one. 3, 1, 1. 1 and 1 can be methyls only, but 3 can be what? 3 can be a propyl or isopropyl. So 2 ways will be there. Okay. Which is propyl, nitrogen, methyl, methyl. Isopropyl, nitrogen, methyl, methyl. So how many tertiary we got? 1 plus 2, 3 tertiary. So answer is 8 plus 6, 14 plus 3, 17 is the total structural isomers. Okay. I hope it is clear to all of you. It was my motive to teach you to how to draw the isomers very fast by knowing the alkyl isomerism. I hope it is clear to everyone how to draw them very fast. This 17 I could get the answer within half a minute. If I didn't draw them, we could get the answer within half a minute. Now you practice the same thing. Pause this video or watch this video again and practice the same thing for the following molecules. Practice the same thing for the following molecules. C5H10O structural isomers. Tell me in the comment box with the questions, C5H10O, these many isomers I got. Just structural I am asking you. Practice for C5H10, only structural. Practice for C5H10O2, only acids and esters. Practice for C3H6O, only open chain compounds. Okay, no ring compounds, only open chain compounds. This one is an important one. And let us see what answers do you give me. I hope it is clear to everyone. It is a very important topic for the NEET, and make sure that you subscribe to the channel. First note down these questions. Okay, pause the video, note down these questions, and then please make sure that you are subscribing to the channel and waiting for more such interesting videos to come. Okay, thank you very much and see you all soon. Bye bye.